Hello everyone, welcome back to my channel. So today we will discuss the questions which were asked in the LTIMindtree second round technical interview. So if you have not watched the first round video yet, please watch it first. You can find the link in the description box. Okay. So this technical interview lasted for around 1.5 hours and it included many critical technical questions. So I have noted all of them down, which will help you to prepare for your upcoming Power BI interview. So let's get started without wasting any more time. So coming to the first section, there were a couple of data warehouse questions which were asked. So the first question which was asked is, what is SCD? So you should answer like, SCD is a technique which is used in data warehousing to manage changes in dimension data over time while preserving historical information. Okay. So then the next question was, what are the types of SCD? So you should start like, there is type 1, type 2, type 3 and type 4. And there are two other types, that is type 5, type 6, which we normally do not use. And then you should start explaining each of the type in one single line. So what does type 1 does? It overwrites old data and there is no history is maintained. Okay. We will explain it for type 1. Then for type 2, you will explain like, it creates a new record for every change. And here the complete history is maintained. Okay, so here the complete history is maintained and we'll explain it with the help of an example. So suppose there is a table which records employee ID, employee name and job location of the employee. Okay, and start date and end date, he has started working in that location. So suppose the employee has changed his location from Mumbai to Bangalore. Okay. So in SCD2, that record will be counted and that record will be stored in the same table. Okay. So how it will mark it? So suppose the job location start date was from 1st January 2024 and end date is 30th June 2024. So it is marking the end of that working in that particular location by a end date. Okay. And then again he has started working in another location in Bangalore from 1st July 2024 to 31st July 2024. Okay, but this is also one of the historical record, but currently he is working in Pune. So 1st August 2024 and the end date is marked by null. So this is how, I mean, in SCD type 2 the current data as well as the historical data are maintained. So the current data, the end date is given an arbitrary value or a null value to verify that this is currently, this is the current location or the current data. And then you can preserve it by another column by saying that is it the current. If you mark it as yes, then you will be able to fetch that particular row which is the current data. Okay. So this is how the data is maintained in SCD type 2. The historical data or the historical locations of the employees as well as the current location is maintained in the same table. So for type 3, you can say SCD type 3, it adds a new column to store the previous value, that is current minus 1 value, and it maintains limited history. So this is properly you should answer like this, that it only stores the previous value, that is current minus 1 value. This is very important. You should mention this point, current minus 1 value, and it maintains limited history. What does it mean? That here all the historical records of John is maintained, right? Wherever the locations he has changed from Mumbai to Bangalore or any other location, if we had changed, then it would have been stored for SCD type 2. But for SCD type 3, only the current location is stored in the table and the current minus 1, only one historical record will be stored. So in this case, only Pune and Bangalore will be stored for SCD type 3. So it stores only limited history, that is the current value and current minus 1 value. Okay, so you are cleared with SCD type 3. So in SCD type 4, the current data is maintained in the original table and while keeping the historical data separate in another table. So SCD type 5 and type 6 are hybrid types. It basically consists of type 1, type 2, type 3. Okay. But the interviewer would not be very much interested in knowing these types. So you can tell up to type 4. Okay. Coming to the next question, what is the difference between star schema and snowflake schema? So this is one of the most important questions which is asked in as a part of data warehousing concepts in a Power BI interview. So very important question, and you should be answering it like that. In star schema there is one fact table and there are multiple dimension tables, okay, but each dimension table is connected to the fact table by a one-to-one or one-to-many relationship, okay. But in Snowflake schema there is one fact table and there are multiple dimension tables connected to the fact table, similar like a star schema, but each of the dimension table is further normalized to two more dimension tables. So each of the dimension table which is connected to the fact table is further normalized to two more dimension tables, okay. So let's quickly understand the difference between star schema and Snowflake schema using this picture. So in both the diagrams, the large box in the center represents the fact table, okay. So this table contains business metrics like sales, profit, quantity and revenue, okay. So on the left hand side we have the star schema. Notice that the small tables around the center are the dimension tables, okay, such as product, customer, date and location. So each dimension table is directly connected to the fact table, and as a result there are fewer joins and the model is very simple and queries also run very fast, okay. So on the right hand side we have the Snowflake schema. Here you can see that the fact table is connected to the dimension tables similar to, but those dimension tables are further splitted into smaller tables, okay. So that's why you see additional small boxes which are connected to the dimension tables. So this reduces duplicate data but increases the number of joins and makes the model much more complex, okay. So in short, just remember, star schema means fewer tables and better performance, while Snowflake schema means more tables but less data duplication but more complexity. Since the dimension table is broken into two normalized dimension tables, so every time we need to retrieve the data from the main dimension table, the two child dimension tables needs to be joined. So for each dimension table the join action has to be performed. So the number of join operations is increasing, which is reducing the overall query performance in Snowflake schema, okay. So another some important points you can tell that in star schema the query performance is very fast and it is also less complex and easier to understand, but Snowflake schema is slightly slower due to joins and it is more complex structure, okay, and it is very better for complex relationships. Negative point in star schema as we have denormalized dimensions, but in Snowflake schema the dimensions are highly normalized, okay. So these are some of the differences that you can mention for star schema and Snowflake schema differences. So the next follow-up question is that why do we need a Snowflake schema? So the interviewer asked, like, even if if there is star schema and it is less complex and the faster query performance we can get in star schema, then what is the need of a Snowflake schema, okay. So you should answer like, Snowflake schema is used to reduce data redundancy, improve data integrity and efficiently manage large and complex dimension tables, okay. So in terms of larger tables with large amount of data where there is huge data redundancy, Snowflake schema can be an option as a dimensional modeling to reduce data redundancy and to improve data integrity, okay. So the next question was, what is fragmentation? So fragmentation is the process of dividing a larger database or table into smaller pieces, okay, in order to improve storage efficiency, query performance and scalability, okay. So this is how you should answer what is fragmentation. So another question which was asked was, what are the three business use cases you can go for Snowflake schema? For the first business use case, in case of large data, large retail data warehouse where there are huge number of products and its categories and subcategories. So there are huge amount of data which will be stored in a table. So in that case, you can go for a Snowflake schema data model because the data hierarchy is very large. Go for Snowflake schema in order to reduce the data redundancy and to improve the data integrity. So first case is where there is a deep hierarchical data. There is a large amount of data and it follows a deep hierarchy. So in case of retail data warehouse, there is product type, category, subcategory, the name of the product. There is a larger deep category. So maintaining it in one single table, it will contain a lot of data redundancy, okay, and duplicate data. So in order to remove that, we can go for Snowflake schema. Then the same another domain you can give is banking domain, where we need to organize customer, city, state, country hierarchies with minimal redundancy, okay. So we can take another example for healthcare domain, where we have to maintain a lot of patients' name along with their city, country, district, region, okay. So a lot of patients' data has to be maintained along with other locations of that patient or hospital. So this is also a large hierarchical data. So a very good example of implementing Snowflake schema. So coming to the SQL questions, the first question which was asked was union versus union all, and which one is faster. So you should answer like, the main difference is that union removes duplicate rows, whereas union all returns all the rows including duplicates, okay. And union is slower because SQL has to compare the records and eliminate duplicates using sorting techniques and hashing techniques, whereas union all is faster since it simply combines the result sets without any duplicate check, okay. So you can answer like this, that union all is overall faster than union because it doesn't has to remove duplicates and it simply combines the results and gives the output, okay. If duplicate removal isn't required, then union all is preferred option for better performance, okay. So you can answer like. So coming to the next question, a SQL hands-on problem was given to him. So the table consisted of bill number, product, category, brand, store, city and quantity, okay. And the ask of the question was, he wants the sum of quantity city wise as well as the sum of quantity store wise. What does it mean? That he wants the sum of quantity as a part of aggregating product, category, brand, store, okay. So these four columns aggregation will give the sum of quantity for store, and he wants the sum of quantity city wise, which will be doing the aggregations on the basis of product, category, brand, store and city, okay. So they want two columns in the same table which will perform aggregations on the basis of 4 columns and 5 columns to give store wise aggregation and the city wise aggregation. So it is clear, right? So I have done the problem. It is a very simple problem. So select bill number, product, category, brand, store, city, month, quantity, okay. So I am selecting all the columns from the original table. I am just performing a window function, sum of quantity over, I am doing partition by product, category, brand, store, city. So it will be performing total quantity city wise, because the city wise calculation is doing aggregation on 5 columns: product, category, brand, store and city, okay. So it will give the sum of quantity city wise, and then I am doing another aggregation which is performing sum of quantity over partition by product, category, brand, store as total quantity store. So these 4 columns, product, category, brand and store, will give store wise aggregation from goods store, okay. So coming to the Power BI question, the first question which was asked, that what are the different Power BI storage modes? So the answer is import mode, direct query mode and live connection mode, okay. So the next question is import versus direct query mode, and when we will use which one. So there are some criterias you should tell, that for direct query mode, when the amount of data is very large, okay, we should be going for direct query mode. And when we require real-time data, and when the data needs to be frequently updated, we will go for direct query mode, okay. And we will choose import mode when we want a better report performance. We want faster report performance, faster slicers, faster dashboards. We'll go for import, okay. And we will go for import when we want to go for complex data modeling, when we want to create or connect to data from multiple data sources and we want to perform complex data modeling, then we will go for import mode, okay. So these are the two important points you should give. Then another point you should give that if the refresh time is taking if it is taking more than 1 hour, then we would go for direct query mode. So in import mode, if the refresh time is taking more than 1 hour, then we would go for directly to direct query mode. Okay, so these are some of the points that is very much important in determining the choose between import mode or direct query mode. Okay, so 4 follow-up questions were asked after that where is the data stored in import mode. So you should be telling that the data in import mode is stored in Vertipack, which is the in-memory engine of Power BI, and the data is stored in form of datasets and semantic models. Okay, so coming to the next follow-up question, how much dataset size above which we should use direct query mode. So you should answer like, for an approximate estimation, any dataset size above 10 GB should be used as a direct query mode for faster performance and maintenance. Okay, then for the next question, refresh time taken above which we should use direct query mode. Okay, so what is the refresh time above which we should be using direct query mode? So for an approximate estimation, if the refresh time is taking more than 1 hour, so first we will try to reduce the refresh time by implementing incremental refresh, or we will try to optimize our data model. Okay, so we will try to optimize our data model by reducing unnecessary columns from the data model, by changing the data types correctly. Okay, we will try to optimize the model, and if it doesn't happen, then we would choose direct query mode. Then the next question was, what is the difference between security and governance in between these modes? So you should answer like, in import mode, data is stored in Power BI datasets, whereas in direct query mode, data remains in the source database itself. Okay, and security should be managed in both Power BI and the source for import mode. But in direct query mode, source database security is enforced directly. So you can maintain the security in the source itself because the data is stored in the source. Okay, so for import mode required schedule refresh to keep the data updated, but in direct query it always shows the latest data from the source. Okay, because it uses a schema of the data source. Okay, so import mode, there is a high risk if sensitive data is copied into Power BI. So for direct query mode, it is better for highly sensitive data since it is not stored in Power BI. Okay, so for import mode, RLS is applied in Power BI after the data is imported, but for direct query mode, we can leverage both source level security and Power BI RLS on the data. Okay, so the next question was, which tables we should import and which tables we should be using as direct query and why. So we should import dimension tables and we should use direct query for fact tables. Then we will give you explanation like, this is because the size of the fact tables are very large. This is the number one point, and it frequently changes. Why it is so? Because it stores the sales data, profit amount, discount amount. So these are all transactional data which happens on a daily basis, and the data changes very frequently. So we need the updated data, and that's why a direct query is a better option. Okay, so this data needs to be updated frequently. And for dimension tables, we should be importing dimension tables for a faster report performance, because dimension tables, the columns are mainly used in slicers or filters. Okay, so these should be imported for a overall faster report performance, and we cannot use dimension tables under direct query, because if we use direct query for dimension tables, every time when we click on a slicer or a filter, it will send a query to the underlying data source for retrieving the data, and every time you will click on a filter value or a slicer value, you will see there is a loading option, and it will take some time to filter the data. So that's why, in order for overall report performance or faster report performance, we should be using import mode for dimension tables. Okay, so if you want this document which has all the answers along with these questions, simply write your email ID in the comment box. I will personally send that document to your email ID. Okay, just write your email ID in this comment section and I will send the document to your email ID. So if you like this video, kindly like and subscribe to the channel to get more videos like this, and which will help you to prepare for your upcoming Power BI interview. Thank you so much. It will really motivate me a lot.